Hi students, welcome to YourPedia education and welcome back to the NPTEL questions module, that too electrical machines in electrical engineering branch. So this is the NPTEL book which will be given to each student who will purchase this one, and in this one we will provide all the questions which were asked in the previous NPTEL online courses. Okay. So along with the solutions, means we are providing the both paper solutions as well as video solutions for each and every question in this book. So this is the electrical engineering book. So similarly you will have different branch books also will be there. Okay, now let's discuss the question number 21 in electrical machines. Question number 21 in electrical machines. If you check with this question, so directly by looking at the diagram itself, you will confirm that this question is regarding the three-phase transformer. This question is regarding the three-phase transformer. Now let's dive into the question and let's explain. Let us discuss the concepts regarding this one, and as well as we'll discuss the solution. Actually, the solution for this question is very simple. It will come in only one or two steps only, but you need to learn the basics. Once you learn the basics, then it will be easy for you to answer any kind of questions, whatever it may be, whether it is single phase transformer or three phase transformer or whatever it may be the subject. So first you need to learn the fundamentals. So once you are perfect in the fundamentals, the cracking of any question will be very easy. Now let's start this question. So a three phase three single phase transformer, two winding transformers are connected as shown in figure to form a three-phase transformer bank. So he has taken three single-phase transformers and he connected these three single-phase transformers in a three-phase bank. The high voltage windings are denoted by capital ABC, means these left-hand side are the which one? High voltage windings, and the low voltage windings are denoted by small ABC, that are these right-hand side windings are low voltage windings. If a three-phase line-to-line 220 volts is applied across the high voltage terminals, so between A2 to B2, he is applying how much voltage? 220 volts. That to line 220 volts. So what is the LV side terminal voltage and its phase with respect to the corresponding HV side terminal voltage? The turns ratio of this transformer he has given as 6:1. 6:1. 6:1. Now if you check with this question, what is the question he is asking us is, he is asking us to calculate the voltage across these two terminals. Yes or not? So if you want to calculate the voltage across the LV side terminals, first you need to learn, or first you need to understand, so how much phase difference you will get from this winding to this winding, means between the induced EMF of this winding to this winding, how much amount of voltage difference or phase angle difference you will get. That is the first thing you need to learn. Then after that one, then you need to calculate the line to line voltage as well as phase voltage. Both must be required to solve this question. Okay, now let's solve this question in a quick fashion. So what is the question is, he has given three single phase transformers connected in a star bank. This is a star bank. So our star bank or star connection. Now first you need to check the outgoing terminals, either outgoing terminals or either incoming terminals. First you need to check. If you check with the neutral side connections of both sides, because both neutrals taken out at A1, B1, C1. If you take HV winding side, A1, capital A1, capital B1, capital C1, can group together and connect it to a neutral point. So, and he placed a dot at this A1, B1, C1. Similarly, check the A1, B1, C1 on the LV side winding. So if you check with the LV side winding A1, B1, C1, again they are grouped together and connected to the neutral terminal, and dots are also placed at the A1, B1, C1 on LV side also. If you check with this one, So the phase angle difference between the primary winding or HV winding to the LV winding will be zero. Why? The outgoing terminals or incoming terminals both are similar connections, are similar points, similar operating points. So capital A to capital B to capital C to are similar to small a to small b to small c to. To understand this one, let's take a single phase transformer. Into consideration. So this is the single phase transformer. Forget about the number of turns. So what is the usual operation of transformer you might have studied is, we will connect a single phase AC source here. So a sinusoidal voltage source will be connected here. So because of the sinusoidal voltage, what will happen is some current, time varying current will produce or circulated in the core of your transformer. So because of that flux linking the secondary winding, we will get some induced EMF in the secondary. So let me take dot here. So based on the sense of winding or based on the current directions, so one current is entering means another current must leave, because transformer is a negatively coupled device. Yes or not? So if you check with the induced EMFs E1 and if you check with the induced EMFs E2, so if you draw the phasor diagrams, you might have remembered the phasor diagrams. So this is the flux phasor waveform. So the induced EMF E2 will be in this phasor, that is exactly 90-degree lags with respect to pi, and the value of E1 is also in phase with the E2, because the same flux is linking the secondary winding or LV winding and along with the HV winding also. So you will get some induced EMF, we call it as a self-induced EMF, that is E1 is self and E2 is mutual. So the same flux is causing both the EMFs, that is the reason both the EMFs are in phase in nature. So both the dots has the same polarity of induced EMF, That is the why I have placed one dot here, means another dot is placed, means one dot is mentioned as positive, means another dot must be mentioned with the same terminal voltage, that is positive value only. So by taking this into simple reference, now what is the polarity of induced EMF at A1, A2, B1, C1? If you check this as a positive value, then you need to place here is also positive. So if you represent this as a negative value, so because this is connected to neutral, so we'll always represent the connection with the negative value, which is connected to neutral point, we usually represent with negative. So if you represent negative A1 as a negative, obviously or compulsory you need to select A1 on a LV side must be negative also. So this is negative, you will get this is also negative, this is also negative. So the polarity of voltages, both A2 phase voltage with respect to A1 will be positive, B2 phase with respect to B1 is also positive, C2 phase with respect to C1 is also positive. Similarly, LV side, A2 phase with respect to A1 is also positive, B2 phase with respect to B1 is also positive. Similar kind C2 phase with the C2 in phase C2 with respect to C1 is also positive in value. So all the voltages are in positive values and all are having the same polarity, means same phase reference. So that is the reason how much amount of angular difference you will get in between these two voltages, because both sides you will have star connection. So both sides star connection means voltages will be differed by based on the number of turns, but the phase angle difference between those two connections will be decided by the outgoing terminals or incoming terminals, based on the outgoing or incoming. So if you check with the outgoing terminals on LV side and HV side, both are similar connections, both are similar points, similar operating points, are similar type of connections. So A2, B2, C2 are the incoming terminals, and A2, B2, C2 are the outgoing terminals. So same terminals we have taken out from the transformer, so that this transformer doesn't have any phase difference between your primary side voltage to secondary side voltage. Primary side voltage to secondary side voltage. So as there is no phase difference between these two, so what is the answer you may get? You may get the answer 0 degrees. Which options are matching the 0 degrees? Either A or C. So I can eliminate with this analysis, I can eliminate the option B and D. Now you will get a 50% probability of getting the right answer. So previously you have 4 options, only you have a 25% probability to get the, means even if you guess the answer, if you guess any answer, you have a 25% probability. But now based on the elimination of the options, now we got an increment of 25%, another 25%, means now you have 50% probability of getting the 1 mark from the given question. Okay, now what you have to do is, let me answer this question. So as there is no phase difference, now let's check the voltage on primary side. How much voltage we are applying? 220 volts. So primary side or HV side, line to line voltage is how much? 220 volts. Now on the secondary side or LV side, how much voltage you may get? LV side line to line voltage, how much you will get? We'll get the voltage as how much? So just take the turns ratio. So take the turns ratio. This is what first we need to calculate, because we got the phase difference value. Now so V2 by V1 is equal to N2 by N1. So what is V2? That is your LV side line to line voltage we need to calculate. Our phase voltage first we need to calculate actually. So turns ratio is always based on the what voltage? Phase voltage only. So this is the LV side phase voltage. These voltages are phase voltages you need to consider. Always these are phase voltages only. Now HV side phase voltage, HV side phase line to neutral voltage we need to take. Okay, which is equal to N2 is 1 and N2 by N1 ratio is 1:6. We have 1:6. N2 by N1 is 1:6. So now let's calculate the voltage on the secondary side or LV side. Phase voltage first. So LV side phase voltage, which is equal to HV side phase voltage by 6 will get. So what is the HV side phase voltage? It is 220 by √3 is the phase voltage of HV side multiplied with the 6. So you will get the value of phase voltage on the LV side. How much voltage will get is 21 point, how much? 21.16. This value is 21.16 volts. So this is the LV side phase voltage. This is magnitudal value we got. So whatever the value we got, this is the magnitudal value. Suppose if you want to represent this voltage in terms of phase, LV side phase voltage representation in terms of phasor quantity, its value you need to represent as 21.16 at an angle 0 degree volt is the phasor representation. Now, but what is the question he has asked? He is asking us to calculate the what is the LV side terminal voltage and its phase voltage phase with respect to the corresponding HV side. See, terminal voltage means it is always a what type of voltage you need to calculate? Terminal voltage means in between two terminals you need to calculate, that is line to line voltage. So let's calculate the line to line voltage. So let's calculate the line to line voltage on which one? LV side. So LV side line to line voltage or line voltage, which is equal to √3 times of LV side phase voltage, we need to take. So root 3 into 21.16 at an angle 0 degree. So which will give you 35 point, which will give you 35 point how much? 36.65. 36.65. So 36.65 at an angle 0 degree. So which option is matching this question, this value? Option C is the right answer for this question. Option C is the right answer for this question. So this is how you need to attempt these questions. So this is a simple basic question, but if you learn that basics from each and every subject, it will be easy for you to crack the any exam. Okay, thank you, all the best.